Hello. What we are going to start is really talking about computer programming, pseudocodes. This is stage one. So we're going to be looking at inputs, outputs, and calculations. Let's go on to. When you get time, I would like for you to look through what is programming. So after analysis, what's next? After we find the and we do the IPO table, we have identified inputs, processes, and outputs. Where do we go next? After that, we have to build pseudocodes, algorithms, or even to use flowcharts. And then of course we need first of all to get some important concepts in. So as we go along this whole course, I will be introducing you to some concepts. The course is not only about just programming, it is about understanding certain important concepts, and CXC like to ask you about those things. Right, so one of the more important concepts, which is like the building blocks of all programming languages, are sequences, selections, and loops. But as you can see here, sequences are in one instruction after the other. And that's what we have been doing mostly so far. And you all have been looking at questions that were dealing with sequences, where they ask you for perhaps a number, you have to double the number and then output the number. First of all, it was input to a number, you do a calculation, and then you output. So that was one instruction after the other. Then of course there is also selections or decisions, and in that case a choice or decision has to be made if the condition is met. Normally you would see that disguised in certain ways, or it could just be plain with an if statement in the problem statement. Finally, there are loops or iterations. Loops or iterations are not sequences, sorry, are instructions that have to be done over and over and over again. It may include sequences within it, and it may even include selections or decisions within it. How you will spot that? You would look for things like, for a class of 35, repeat until, or perform certain tasks until a certain condition is met. That's how you would spot loops. So let's look at another important concept which I want to clarify so that you wouldn't get doubtful about whether it's algorithms or pseudocodes. Now in CXC, if they use the word algorithms and you know the pseudocode for it, you can write it. Similarly, if you know the algorithm, you could just write the algorithm alone. But what is really algorithm and what is really pseudocode? First of all, pseudocode stands for false code. Algorithms, on the other hand, is a step-by-step method of solving a problem, and it could be written in normal, plain English statements. So it could be very wordy, it could be explaining things, and unlike pseudocode, it isn't shortened, it isn't following any structured code, right? So pseudocode is a detailed yet readable description of what a computer program or algorithm must do, expressed in formally styled natural language rather than in programming language. Pseudocode is sometimes used as a detailed step in the process of developing a program. It allows designers or lead programmers to express the design in great detail and provides programmers a detailed template for the next step of writing code in a specific programming language. So as I say here, many students get confused as to how to write algorithms and whether it is acceptable when compared to pseudocode. Well, you know, you are a budding programmer, so I would like for you to learn how to write pseudocode instead of writing the long English-like and wordy statements like the algorithm. But let us say you feel comfortable at this stage writing algorithm. There's no problem with that. In fact, as we go along, we're going to see that you can write algorithm and you can then change it into pseudocode. That's how we're going to be developing things. So there's no hard and fast rule at this stage about whether you're writing algorithm or pseudocode. Good. So let's start now. We want to learn how to write input statements in algorithm style or pseudocode. when a user has to enter a value, that value is accepted and stored in a variable. Therefore, inputting has two functions really. One, to accept, and secondly, to store the value. So many times you will hear that input really is about accepting and storing. Let us look at one of the examples that we did in the IPO table, and I'm only pulling out this side here, which is the input from that IPO table. So this is the inputs column, and in the inputs column I had written YROBRT, which stood for year of birth, and this one was current year. So those were the two inputs. Well, we want to learn how to write the algorithm, and then of course I'm showing on this side here how to write the pseudocode. So the algorithm for that would have been plain old accept year of birth and current year and save. If you notice, they use the word accept, they could even use the word and then and save. But it must be understood that we are doing inputs, so therefore you have to accept and save. Unlike the algorithm, however, pseudocode tends to use the words read, enter, or even input. So in this case, you say read year of birth and current year. Now remember, these are variables. So therefore, I have to use the same variable that I used when I was accepting here. Okay? Let's move on. Or you could have said read, so this is entering both on the same line, or you could have said read year of birth and read current year separately. Let's look at another one. Another one was to input num, which was from the IPO table. To write that in algorithm style, we say enter a number and save it. In the pseudocode, we say input num, because again we use the variable called num, and therefore in the pseudocode we should be following some sort of conformity and use the same name that we have used in the IPO table. So a little note here, from now on algorithms will be shown once because I don't want to waste time developing algorithms and then developing pseudocode. I just want you to know that algorithms are more wordy in English and it's free to write. Once you could solve the problem in your mind. That's another thing. You have to try to solve problems in your mind and try to think about how best you will say it. Move on. So let's look at input statements in pseudocode. Continue prompting for input. So let's see now. Right, we want to know that here what is it, well, what you should be looking at is, I see the cursor flashing, what am I to enter? Have you ever come across some programs that when you start the program, you are seeing that the cursor is flashing and you're wondering, what I should enter? What is necessary to be entered? Well, that was perhaps a little fault in the programmer not giving you appropriate prompts for the input. What you will see from now on is that I am saying to you, every input should have a matching prompt. In order to tell the user what must be entered for input, a prompt is normally displayed to tell them what to do. So, prompt before an input is done. So let us look at this case. Again, year of birth and current year was from the IPO table that we identified. To write it in algorithm style, we say display, enter your year of birth and current year. As well as, then of course, this is just the prompt. The red part here is the prompt. Then we're going to accept and store it here. Accept year of birth and current year and save. Again, the pseudocode for that would have been just to merely use print, enter your year of birth and current year. And then the pseudocode for accepting and storing is read year of birth and current year. Again, a little note here is algorithms is like normal English. Let's move on. Writing input statements now in pseudocode continued, prompting for input. So this time we are prompting for the input again. Let's look at this question. Write a pseudocode to enter the radius and height of a cylinder and print out the volume. Well, if I were to analyze this question, I would realize that the inputs were the radius and height because I saw the word enter. Simple. So in my IPO table, I would have had this part, radius and height underneath inputs. The algorithm for that would have been display enter radius and height of radius cylinder. This area here, this line here is the prompt. This part here is saying to accept and save. Okay? So once there is input, there are two parts to the input when you are writing. The prompt line and the accepting and saving line. Similarly, in the pseudocode, to write that prompt first of all, you say print, use the word print, enter radius and height of cylinder, and then you put a line to say to accept and save, read radius and height. So in pseudocode, read is the same as saying accept and save. Let's go on. Well, I have here some questions for you to look at, and it's important that you practice, because it is only when you practice then you will be able to know if you are understanding. So I will like for you to do these questions and come with them to class so that I can just quickly check it through and we can move. Right, we are looking at writing pseudocode now for output. When we identify through the IPO table that there is output, it will be necessary to convert from the IPO table that output into pseudocode. To do that, we can use the print or the write command to write it in pseudocode. The syntax for it is simply to use the word print or write followed by a variable name and another variable name if there were two necessary to be printed. You should note that from now on, syntax means the basic structure that it will follow. You can output string. Now string are words like names and addresses. Those are string variables. Or you can output, so string are words or names and addresses, or numeric variables, which would be numbers. Example, let's look at an example. So we saw in the IPO table that there was output for name and score. So therefore, we write the word print name and score. But what happens? Now let us look at first what was input. The input was Jane Dove that was stored in name and 78 was stored in score. When we print name comma score, what we will see showing up on a screen would be Jane Dove and 78 because these are the values that were saved in those variables called name and score. Let's look now at outputting a string constant. A string constant is anything that we want to print that is not in a variable, but we need to just print out what is within that quotation mark. So the syntax again, we use the word print, and instead of putting the variable name, we use quotation marks, double quotation marks, and we write the string inside of it. Example, print Carlos is my name. On the screen you will see Carlos is my name printed. Print time, the word time will be printed. Print prod equals 4 by 5, and you will see printed on the screen prod is equal to 4 by 5. Let's go on to the next one. Let's look now at writing pseudocode for output with labels and variables. So the heading is outputting a string constant and a variable. Now previously we looked at printing a string constant using double quotation marks. This time we want to look at printing the string constant and the variable. For example, if 4.35 is printed by itself, you may not know what it means unless a descriptor or label goes along with it, such as the total cost is $4.35. So therefore, the syntax now is to use again the word print, followed by the string constant, and then the variable name. So if ever they ask, display the cost together with an appropriate label, they really mean print the total cost is followed by the variable, which is cost. So example, print the total cost is in double quotes, comma, and the variable name cost. This will show the total cost is $4.35. If I print hello in double quotes followed by name, and if the value David is stored in the variable name, this will show hello David. Let's go on to the next one. Well, the next one means that you have to try to see if you could understand and see if you are learning. So note always identify your inputs, processing, and outputs. That is, remember the IPO table. The IPO is, let's look now at writing pseudocode for calculations. First of all, in calculations, we use the plus, the minus, the backslash for divide, and the asterisk for multiplication. The equal sign in a calculation statement is known as the assignment symbol. So therefore, we would be looking at A equals B plus C, which really means the variable A is assigned the result of the calculation of B plus C, so that the memory location A will now hold the result. It will now hold the result of the calculation performed on the variables B plus C. So let's look at an example. Write a pseudocode to enter two numbers, N1 and N2. So that was the input. Find the sum and print out the result. Find the sum was the processing, print out the result. So in this case here, we need to find the sum, which is the calculation. The calculation pseudocode statement is sum is equal to N1 plus N2 and is read. Sum is assigned the calculation of N1 plus N2. So this here is what you need to write in your pseudocode to show that you are doing a calculation. Let's go further. Again, now you have to do your part by performing these questions and doing them for homework. Alright, some questions here, just a little note, some questions are there to trick you, and you will try to figure out why they are trying to trick you. And of course, note always inputs, processing, and outputs. You must try to identify inputs, processing, and outputs, and remember the IPO table. The IPO is where every programmer starts. So despite again this question